stuff. Um, so this parent function stuff, basically what that is it's basically just your most simple form of a graph, or like the simplest form that you can get of a graph or of a function. And then all other functions that are kind of members of that same group would come from that, and they would just go under some sort of transformation, whether it's like a size change where it gets like bigger, scale change where like the one dimension goes by something and then another dimension goes by something else, or like translations where we slide, rotations, all of those different things. But parent function is just like the most simple form of those graphs. In those packets, there's a whole bunch of examples of the parent function, so maybe we should write here that these are the parent functions. I think it's on like the second page of the packet. But there's a whole bunch of different functions there that are all like your most bare bones basic form of it. So like, just the straight line linear one is just an x with a slope of 1 and a y-intercept of 0. So like just the basic one, the x squared one, no numbers or anything with the x, nothing added or subtracted at the back. So just the basic ones, and then you're going to take and you're going to do something to those to make new versions of them. Okay, so that's that stuff. So instead of drawing it, we'll just put it in those packets. And then a family of functions is basically when you kind of build off of those parent functions. So say we had like the parent function for like the absolute value of x1 that's kind of like that. You would do something to this graph here. So maybe like we took it and we like slid it over to the right and then we made it like skinnier or something like that. That would still have similar characteristics to the absolute value of x graph because it's kind of like that V shape, but there's things that kind of changed about it, but those would still be in the family of functions because they still resemble each other because they're still both those V-shaped graphs. And then window there, we're going to do a lot of stuff with changing our windows around. Most calculators have a standard window. On our TI-84s, it's always going to be like the -10 to 10, and then same with the Y, the -10 to 10, which you guys probably already knew that, but if it asks in the book something about like a default window, that's kind of what they're talking about there. You just hit like zoom standard or Z standard when you go on your zoom. Asymptotes, we've talked a little bit about this before, but basically your asymptote is a line that your graph can get really, 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 really close to, but it never crosses that line. So in this case here, you've got an asymptote there at x is equal to -5, and you would also have an asymptote going across there at, what would that be? That'd be y is equal to 0. The reason that this one's got that dotted line, that's just how they mark asymptotes, as long as they're not the x or the y axis. So like this one didn't get a dotted line because it's the x axis, but that would be our asymptote there at -5, marked in with that dashed line. So again, it gets really close to it, but it can't cross that. Reason being, and why that happens at the x, is if I put a 0, or if I put a 5 in for my x there, so like 1 over 5 minus 5, what is 5 minus 5? 0, right? And can we ever divide by 0? No. So because we can't divide by 0 like that, our x value can never be that number, so that's why it kind of has those weird things happening to it. Okay, so that's an asymptote. So the next thing I'm going to have you guys write here is also kind of a weird situation here that I don't know if you've seen a whole lot of before. So I'll let you guys jot that one down and then we'll talk about that. If you can't tell too, this is an open circle here, and this one's a closed circle. So the top one's a closed circle, the bottom one's an open circle. I'll pause my video so I can talk to you.